Hello everyone and Assalamu alaikum. I'm Awais and I will be hosting today's session. First of all, I would like to welcome you all on behalf of DICE Analytics for today's session, Career in Artificial Intelligence. I am glad to introduce our speaker today, Mr. Hassan Aftab, who will be leading this session. Mr. Hassan is currently working as lead data scientist in telecom industry. He has 6+ years of working experience in top telecom and fintech companies. Hassan had pivotal role in delivering crucial business solutions and completed several data science certifications to upskill his knowledge in this domain. He has accomplished associate's degree in AI and ML from Udacity and many other certifications from LinkedIn Learning Platform. It's a request to all of the attendees to note your questions during the session and ask your queries in the Q&A session at the end. Thank you so much. Over to Mr. Hassan.
Assalamualaikum.
Walaikum salam.
Thank you for sharing the details. So I'm currently teaching deep learning at DICE and also looking over the DSML part as well. So the session is will be pivoting around what we are learning at DICE in terms of deep learning and in terms of how deep learning is basically evolved in last few years, and then what kind of concepts that we discuss, what is the objective that we have. So I'll be basically discussing all of those scenarios. So you guys can, as said by, I don't know the name, I think it was Awais.
Yes, sir, I
You
am
can
aware.
ask your questions in you can ask your question at the end as well, but for me, I think I want the session to be interactive, so you can always raise your hand and ask me question during the session as well. So let's start. Basically, let's discuss what exactly is data science. So when we talk about data science, we see that there are certain different fields, a combination of multiple fields. So it can be computer science, it can be mathematics and statistics, and then it actually adds some domain and business knowledge as well. So when we talk about computer science, and as you can see, it's a Venn diagram, and we can see the inclusive nature of the Venn diagram. So a person with a certain computer science background and having a knowledge in the terms of math and statistics, so can be convert his career into machine learning easily. Similarly, a person with a certain computer skills with certain domain knowledge can be a software developer. And people like having skills in maths and in knowledge, they do traditional research. But as a data science as a whole, if you look at it, it's actually a mixture of all of these three different terms. What is expected by people who are working in data science are to work in all of these domains and have certain knowledge from all of these domains. So a person from only having a math and statistics background without any computer or software knowledge or having programming knowledge is not full capable enough to implement all of data science techniques, and cannot explore all of the knowledge that we can have. And similarly, if you guys have computer science and mathematics skills, but you're not aware of the domain or whatever in domain you're working. So let's say I'm currently part of telecom domain. So in telecom sector, we have certain domain level skills that one person should have to work to act fully capable enough to implement data science in telecom sector. So those business knowledge actually comes up with experience. I mean, it's not something that someone can teach you in a day or two, but it comes up with experience. But full capability जो complete आप मतलब जो पॉजिटिव रिजल्ट्स आप बिल्ड करते हो इम्प्लीमेंटेशन और उसके बाद उसकी प्रोडक्शनाइजेशन एंड देन उसके बाद उसकी यूजफुलनेस और आरओआई इट ऑल डिपेंड्स कि आपका जो अंडरलाइंग बिजनेस है उसकी अंडरस्टैंडिंग कितनी है, हाउ मच यू आर इक्विप्ड विद द बिजनेस. सो इट इन्वॉल्व्स ऑल साइंटिफिक मेथड्स. वो मेथड्स आप लोगों ने जो लोग डेटा साइंस ऑलरेडी पढ़ चुके हैं दे माइट नो कि आपके पास क्लासिफिकेशन रिग्रेशन के मेथड्स हैं. देन उसके बाद क्लस्टरिंग के अनसुपरवाइज्ड लर्निंग, सुपरवाइज्ड लर्निंग, इनके डिफरेंट टेक्निक्स हैं. सो देन वी हैव सर्टेन टूल्स. आर है हमारे पास, पाइथन है, देन नॉन कोडिंग प्लेटफॉर्म्स भी हैं जहाँ पे एज्योर एमएल भी है, डेटा आईक्यू भी है, नाइन भी है. सो देयर आर सो मेनी प्लेटफॉर्म्स आउट देयर जहाँ पे आपके सारे टूल्स यूटिलाइज करके यू कैन बिल्ड अ होल स्टोरी फ्रॉम एंड टू एंड. But so if you talk about how this actually evolves, so first thing first that which is required is अगर मैं इसको टोटल को ब्रेक डाउन कर दूं एक पूरे प्रोजेक्ट को, डेटा साइंस प्रोजेक्ट को, फ्रॉम फ्रॉम टेलीकॉम सेक्टर आल्सो फ्रॉम अदर सेक्टर एज वेल. सो फर्स्ट जो सबसे पहली चीज आपके पास आती है, इट्स ऑलवेज अबाउट बिजनेस पर्सन कमिंग अप विद सर्टेन क्वेश्चन in hand. Let's say as telecom sector has a certain issue of churn, so let's say a business owner comes with a question that let's solve churn. So us case mein business owner has a certain question and we need to acquire data set which is being collected by data engineers and data scientists. So acquisition ke time pe, data acquisition ke time pe, there you can be utilizing multiple data sources. Maybe it can be in-house built data sources, outsourced data sources bhi ho sakte hain, but you need to write different pipelines to acquire and then ingest the data into your whatever source you have. If it can be data warehouse, it can be a certain data model jiske andar aap ingest kar rahe ho. But once a question is there and acquisition is done, then the part comes where generally data analyst and data scientist both are working. इसका objective ये होता है कि you need to explore whatever information that you're having. So either the information is complete or not, and also to look at the different areas, connect the dots with the domain that you have, ठीक है, and try to understand the problem in जो भी आपका जो क्वेश्चन है उसको आप डिफरेंट एंगल से एक्सप्लोर करके देखो, बेंच बनाओ, सेगमेंट्स करो, उसको प्री टू पोस्ट एनालिसिस कर लो, उसके प्रीवियस ट्रेंड्स देखो, मंथ ऑन मंथ ट्रेंड्स देखो, लास्ट ईयर ट्रेंड्स देख के लाओ, ठीक है, सीजनैलिटी ट्रेंड्स भी देख रहे हो आप उसके. सो ऑल ऑफ दोज सिनेरियोज आर कवर्ड इन ईडीए पार्ट, जहाँ पे आप डेटा को इन डिटेल एक्सप्लोर कर रहे होगे. और वंस द ईडीए इज डन, so you have certain insights in your hand, then the part comes where data scientist is involved to model the data. So in terms of analytics, if we talk about, we have certain stages of analytics. So one is the descriptive analytics. As we know, by the name of it, descriptive analytics means कि whatever question आपका जो भी है उस question को answer करने के लिए आप slice and dice करोगे, आप सर्जिकल हो जाओगे अपनी अप्रोच में. यू विल सी के मेरे पास जो भी अवेलेबल डेटा सेट है उसको मैं किस लेवल तक जाके तोड़ के देख सकता हूँ कि वो क्या स्टोरी मुझे बता रहा है. एंड देन फिर डिस्क्रिप्टिव के बाद देन द नेक्स्ट पार्ट कम्स वेयर यू सेइंग कि इफ देयर इज सम इवेंट अकरिंग, जैसा मैंने कहा चर्न का इवेंट है, सो देन यू लुक ऑन डायग्नोस्टिक एनालिटिक्स के व्हाट इज द रीजन ऑफ दिस, व्हाट इज द रीजन ऑफ द चर्न और व्हाटएवर इवेंट जो भी आपके अंडर क्वेश्चन इवेंट है. सो आप उसको डायग्नोज करने के लिए यू आर गोइंग टू सी के जो भी बंदा, इफ पर्सन इज करंटली अ चर्नर, सो वो इट वाज उसका जो लाइफ साइकिल है वो कैसे बिल्ड होता हुआ आ रहा है. सो आपने उसको एक्वायर कब किया था, उसका एक्विजिशन के बाद उसने अपना जो लाइफ टाइम आपके साथ स्पेंड किया, उस लाइफ टाइम पे उसने क्या एग्जैक्टली उसकी एक्टिविटीज क्या थी, एंड देन बिफोर गोइंग टू चर्न क्या क्या चीज़ें जो है वो इन्वॉल्व थी, इधर इट वाज अ डेटा एक्सपीरियंस और इट वाज अ वॉइस एक्सपीरियंस, और अदरवाइज वो फ्रेंड फैमिली का कोई चैलेंज था, आपने उसने अपनी कोई जगह चेंज कर ली. सो देयर इज ऑल डिफरेंट काइंड ऑफ डायग्नोसिस दैट यू कैन रन. Then when the diagnostic analytics are done, then you do know certain key features in hand. It's part of feature extraction. So you have certain features in hand, and you know exactly that these features are related with whatever the problem in hand, whatever the event that you're trying to figure out. And then उसके बाद फिर आप जो है अपने उन features के साथ you try to build a predictive model. So that's called predictive analytics. And then finally you do prescriptive analytics. So what can be done for the certain problem in hand. So जब आप predictive analytics कर रहे हो तो उसमें आपके पास कुछ certain steps हैं, basic steps हैं कि one you try to choose a model, ठीक है, and then you build and train the model, and then you validate, and this step goes on and on and on, because you have multiple models, and then let's say you have a classification problem, so you can try multiple models, maybe नियरेस्ट नेबर मॉडल आपने ट्राई किया, या फिर आपने SVM ट्राई किया, बूस्टिंग टेक्निक यूज की, बैगिंग करके रैंडम फॉरेस्ट आपने यूज कर लिया, डिसीजन ट्रीज यूज किया, आपने मॉडल बिल्ड किया, बिल्ड करने के बाद आपने जो है उसको वैलिडेट किया अपने रिजल्ट्स को कि वेदर द रिजल्ट्स आर एक्यूरेट इनफ टू बी प्रोडक्शनाइज्ड, डिप्लॉयबल इनफ है वो, अदरवाइज यू आर गोइंग टू go back and maybe fine tune your model, or maybe look at other models as well कि वो आप कौन सा choose कर सकते हो, बेहतर कर सकते हो. Once the deployment part is done, then out of time testing भी आप validation के time पे कर रहे थे. Out of time testing mean के एक आपका test set है, and then आप एक certain period के बाद से उठा के testing दोबारा run कर दो, so that जो उसका seasonality impact है वो भी आप जो है वो test out कर लो. एंड आफ्टर द डिप्लॉयमेंट आपका फिर जो रियल टेस्टिंग पार्ट होता है. सो यहाँ पे आप यू गोइंग टू वैलिडेट व्हाटएवर रिजल्ट्स दैट यू आर हैविंग इन योर डेवलपमेंट स्टेजेस, और प्रोडक्शन स्टेजेस में वो सेम रिजल्ट्स आ रहे हैं. सो इस केस में देयर इज अ डिले बिटवीन द टाइम ऑफ इवेंट. सो लेट्स से अगर आपका जो इवेंट जिस इवेंट को आप कैप्चर करना चाह रहे हो उस इवेंट में लेट्स से 30 डेज का गैप है, सो एक्चुअल रिजल्ट्स जो मॉडल के हैं, जो प्रोडक्शन रिजल्ट्स, वो 30 डेज के बाद आपके पास रिसीव हो रहे होंगे. But these results should validate with the development results. So अगर वो validate कर रहे हैं तो then it's good to go. अगर वो validate नहीं कर रहे, then you again go back to your drawing board and see के what are the challenges, if there are any changes in the features, or if there are any certain other challenges जिसकी वजह से आपको अपने मॉडल को retrain करना पड़ा या fine tune करना पड़ा. So all of this part यहाँ तक जो है वो data science and machine learning engineers are involved, and यहाँ पे जो है वो आपके पास DevOps engineers होते हैं जो कि deployment के process automate process भी हैं, continuous integration, continuous delivery के process भी होते हैं, MLOps generally library उसके लिए use हो रही होती है. And then जो data का जो owner है, business owner है, that guy is always trying to figure out कि आपका जो results है वो results accurate है भी कि नहीं है. And then उसके बाद storytelling is the part where you are finally prescribing a certain solution. I mean, if you have descriptive analytics in your hand, diagnostic analytics in your hand, and then predictive modeling in your hand, then finally you are at the stage जहाँ पे आप complete story end to end describe कर सकते हो कि अच्छा एक certain event को अगर होने के लिए कौन से फीचर्स इन्वॉल्व होते हैं, उनकी क्या एग्जैक्टली वैल्यूज होती हैं, अगर आपने जो भी मॉडल डिप्लॉय किया उसमें कौन से इंपॉर्टेंट फीचर्स थे, उन इंपॉर्टेंट फीचर्स की क्या इंटरप्रिटेशन थी, आप सारी जो इन्फेरेंसेस हैं वो सारी डिस्कस करके उस चीज़ को कम्प्लीटली डिलीवर करते हो अपनी टॉप मैनेजमेंट को. सो दैट्स द होल पार्ट ऑफ इट. Anyone from the audience have any question regarding this whole step process? So I'm open to answer, or any confusion around this. Okay, let's move forward. So now comes to the point. So the main abhi tak jo discussion ki there was around data science and how the data science is involved in certain sectors. So AI, what is AI? Can anyone tell? What is intelligence?
सर ह्यूमन कॉग्निटिव एबिलिटी को जब हम मशीन लर्निंग से कंट्रोल करते हैं तो उसे हम आर्टिफिशियल इंटेलिजेंस कहते हैं.
आपकी आवाज काफी आवाज आपकी ब्रेक हो रही है। क्या जब मैं बोल रहा हूँ तो मेरी आवाज ही ब्रेक हो रही होती है?
आपकी आवाज सही आ रही होती है।
Okay, मेरी आवाज clear है। I don't know, for some reason I can't hear you guys. I mean, whatever someone is trying to speak, तो काफी उसमें ना distortion होती है. Anyway, so I didn't exactly get what the person was saying, but so the idea which I got from him is कि cognitive ability को if you're trying to artificially enhance, artificially train your machines to be intelligent enough to take decisions on your behalf, that's called artificial intelligence. And there can be multiple definitions for the AI part, but in a simple understanding should be what we're trying to achieve from AI is that we are trying to make machines think from the past behaviors and then do things for us to make decisions for us, okay, based on all the raw data that we can collect. So some data might have certain patterns that we are not aware of, but it has a relation with the outcome. So what AI is trying to achieve is that it is trying to find those hidden patterns, those layers of hidden patterns, and find those linkages in the raw data and figure out what's there for us, and then obviously make decisions for us. So Mumtaz Zahur, you raise your hand, please go ahead.
Assalamu alaikum, sir. Sir, we
Assalamu.
can say that if we want to develop abilities like human in machines, it's called artificial intelligence. So when we say
Yes.
cognitive abilities,
Yes.
how we react on different tasks on the basis of previous knowledge or previous data. So we want to develop ability like this in machines or algorithms. It's called artificial intelligence. So we can say that like this.
Yes. Sure. Yes. Your understanding is totally correct. So we have agreed.
So it is basically simulation of human intelligence processed by our machines.
Agreed. As I said earlier, there is some challenge. I don't know, for some reason your voice breaks, whoever is speaking. Okay. Anyways, for some reason there is a distortion in your voice, so I'll continue. But yeah, if there is some comment, you can always write in the chat box. I'll read it out. So I appreciate people interaction, but the challenge here is that somehow the voice that I'm getting is distorted, so I'm not able to fully understand whatever the person is saying. So in this visual, if you can see that it's a word AI that is centralized embedded in this whole linkage section, and uske baad aapko nazar aa raha hai ki there are different domains. So you can see a shopping cart, a home appliance, and then appliances, and uske baad aapki stock market hai, aapki medical hai, aapki computer hai, mobiles hai, aapki networks hai, aapki solar systems hai. Each and every industry is dependent on AI. So each and every industry is trying to evolve on AI. So how it is trying to evolve on AI is simplest thing is that we are trying to make machines think and decides for us. So let's say अगर आप shopping cart की बात करते हो, तो there are algorithms in place to figure out what we are, how we can optimize our shopping experience, how we can how the algorithms can tell us कि जी हमारा जो है वो next purchase pattern एग्जैक्टली क्या हो सकता है, नेक्स्ट बेस्ट ऑफर क्या हो सकती है, रिकमेंडेशंस क्या हो सकती हैं, क्रॉस सेलिंग अपसेलिंग कैसे कर सकते हैं. सो ऑल ऑफ दीज यूज केसेस आर बीइंग लेड बाय द एआई एल्गोरिथम्स. सिमिलरली अगर आपने सर्वेलेंस करनी है, आपने कंस्ट्रक्शन करनी है, आपने राइड हेलिंग करनी है, ऑल ऑफ दोज इंडस्ट्रीज आर ट्राइंग टू optimize their decisions based on AI, trying to reduce the cost of implementation, reduce the cost of productionization by implementing AI. And how the AI is supporting this whole process, it is supporting by finding those hidden patterns. So my question would be, how machine learning versus, what is the difference between machine learning and what is the between deep learning? So what exactly is the difference between machine learning and deep learning? Can someone write in the chat? Or maybe you can speak up. I mean, it's fine, you can try. Okay, deep learning is a branch of AI. Okay, you work with statistical formation and learning from a set of data with no restriction. Okay, makes sense. Anyway, so the core difference between machine learning and deep learning is that in machine learning, you are giving the features to your model, right? And those features are being extracted by you. You have done a complete EDA to understand what kind of features are necessarily are relatively important for that certain target label. But in case of deep learning, what you're trying to do is that you're trying to give all the raw data to your data model, deep learning model, and the deep learning. That the word deep is used here because in deep architecture, in deep network, it is trying to figure out all those underlying relations between the data sets. So it is trying to figure out, it's trying to get all the features which are related to a certain target. And the feature extraction ka process that's being automated by the deep learning, by rather than machine learning, where you're trying to tell exactly which features are important, and then उसके ऊपर आप जो है ना वो अपने models को build कर रहे होते हैं. Comparatively, deep learning में the features extraction जो है वो खुद से हो रही होती है, ठीक है? Deep learning is a subset of machine learning. I won't say that. Deep learning is a separate domain of AI, and machine learning is a separate domain. So, anyways, so let's move forward. So in deep learning, in a general view, what we have is that we have a parametric equation which we are trying to basically optimize, and the optimization is kind of, we have a certain loss function, and उस loss function को हम जो है वो reduce कर रहे होते हैं. So उसके लिए there is a process which is called back propagation, and back propagation के अंदर जो है हम वो we try to figure out कि जो भी हमने loss generate किया, so let's say आपने house price prediction किया and house price prediction आपने गलत किया, ठीक है? So जो जितनी आपने गलत prediction की है वो कहाँ से propagate करके आ रही है? So information is being traversed in forward direction, जहाँ पे आपके पास लेट्स से कुछ सर्टेन इनपुट फीचर्स हैं. इनपुट फीचर्स आप जो है वो न्यूरॉन से पास कर रहे हो, उनके ऊपर इनिशियली रैंडमाइज्ड वेट्स आपने अप्लाई कर दिए, एंड वो वेट्स आगे जो है वो एक आउटपुट जनरेट करते हैं. सो जब आउटपुट जनरेट होती है, उस आउटपुट के साथ एरर कैलकुलेट किया जाता है कि वो एरर कितना एरर आ रहा है, एंड देन वो एरर जो है वो बैकवर्ड प्रोपगेशन के टाइम पे हम देखते हैं कि एरर किस weight से कितना error generate हुआ. So for that reason we do take derivatives. You can see you have a certain derivative. यहाँ पे हम लोगों ने equations mention किए हैं. So it is a bit complex process if you look at it. But when we are in this course, जब हम इसको deep learning for AI जब course हम कर रहे होंगे, तो इसमें हम बहुत detail में इसको explain कर रहे होते हैं exactly कि the forward propagation में exactly क्या होता है, backward propagation में क्या होता है, हम उसको एक एक single cell पे तोड़ के देखते हैं exactly कि उसमें कैसे information forward propagate हो रही है, backward propagate हो रही है, और कैसे information को update किया जा रहा है, so that we can achieve our goal, which is true prediction, जो आपने accurate prediction करनी है. So मशीन लर्निंग जिससे हमने बात की थी कि बेस्ड ऑन डेटा एक्सपीरियंस जो आपके पास पास्ट में एग्जिस्ट करता है, दैट एक्सपीरियंस इज ट्रांसलेटेड इनटू डेटा सेट, ठीक है? सो नाउ वी हैव लॉट ऑफ कंप्यूट, डेटा वेयर हाउसेस भी हैं, उसके बाद डेटा स्टोरेजेस बहुत सारी अवेलेबल हैं, कमोडिटी हार्डवेयर को हम एज अ डेटा स्टोरेज यूज कर रहे हैं, And then all of the experiences can be recorded in multiple ways. So we have an architecture of internet and then architecture of microservices, जहाँ पे आप जो है वो सब चीजें IoTs connected हैं, और उसके बाद वो information जो है वो data storages में push कर रही हैं. And then now that we have those all experiences converted into data sets, so we can basically look into those data sets, do call a model to get trained on those data sets, and then predict those similar patterns for future as well. So that's what deep machine learning is trying to do. But what about deep learning? So deep learning is not something which is evolved right now. I mean, AI का जो concept है, it existed back in 1950s as well. I mean, at that time, जो concept जो है वो कि how we can train machines, जब आपके laptops जो है, जब आपके computers जो है वो was there, मतलब उनके evolution के साथ साथ the idea was there कि we can train our computers to get intelligent enough so that they can solve problems that are humanly possible, but कुछ ऐसी problems जो कि humanly impossible problems है वो भी हम लोग solve करवाएं using machines. So 1950s के बाद से evolution started. 1980s में there were certain papers around different algorithms. 1980s में ही आपका जो है वो neural networks का algorithm भी basically जो perceptron का algorithm है, it was presented at that time. 90s में आपको जो है वो आपने लॉन्ग शॉर्ट टर्म मेमोरी नेटवर्क का जो इनिशियल पार्ट है, रिकरेंट न्यूरल नेटवर्क, इट वाज प्रेजेंटेड एट दैट टाइम. एंड देन उसके बाद उसमें इनिशियली एलमान नेटवर्क वाज प्रेजेंटेड, देन टाइम डिले नेटवर्क्स TDNNs वर प्रेजेंटेड, देन उसके बाद फिर वो लेटर स्टेजेस में आप LSTM वाज प्रेजेंटेड. सो बूम हमें बेसिकली मिला जब हमारे पास एक तो इन्फॉर्मेशन हमने कैप्चर करना शुरू कर दी, ठीक है, इन स्टोरेजेस, एंड सेकेंडली ये कि हमने इन्फॉर्मेशन प्रोसेस करना शुरू करी. सो नाउ वी हैव कंप्यूट टू प्रोसेस all of that information. So the idea was there, the algorithms were there, ठीक है, not exactly in the same format that we have right now in today's date, but जो initial papers थे was presented at those times, ठीक है. So even जो आप न्यूरल नेटवर्क्स की इसका जिक्र करते हो, 1980s में पहला पेपर प्रेजेंट हो रहा था, which presented के this parametric equation किस तरीके से सॉल्व की जा सकती है using back propagation where derivatives are involved, so that we can see कि how the change in a loss function can be utilized to basically set a non-linear, to figure out a non-linear pattern. So okay, I was looking at the chat as well. अच्छा, आगे चलते हैं जी. So right now in the current date, जिस तरह मैंने initially भी बोला था कि in 60 seconds जो है ना वो we are generating a lot of data sets. So on YouTube you can see that more than 400 hours of videos are being uploaded. Similarly, more than 200K photos are uploaded in 60 seconds. And इसी तरीके से 70,000 hours का data जो है वो Facebook Watch पे आप देख रहे होते हैं. Netflix में आपके पास जो है वो 87,000 hours की movies देखी जाती हैं. इसी तरीके से जो है WhatsApp पे 1 million photos जो है share की जा रही हैं. So it's a lot of data that we're generating at the moment. And all of these platforms have the capacity and capability and scalability to handle this kind of data. So what are we going to do about it? We are going to utilize this whole information to make intelligent decisions for to optimize our day-to-day activities. So that's the best we can get. So how we are able to do it? We are able to do it by capturing a lot of data. So we have different big data platforms. Then we have lots of compute power available with us. And then there are certain complex problems that we can solve using these technologies. So as when you say deep learning versus other machine learning algorithms, a general philosophy discuss की जाती है कि यार with the amount of data जो है वो as the amount of data increases, deep learning performance increases. Why is that so? The reason behind is that the learning algorithms होते हैं, their learning algorithms are basically trying to fit the problem based on available data, but जो deep learning algorithms होते हैं with जिस तरह मैंने initially mention किया था कि with the more raw data coming in, it's trying to figure out the underlying relationship between all of those features. So with more data coming in, the deep learning model performance gets more better. I mean, comparatively to machine learning algorithms, आपके पास अगर if you have certain data sets, again your model is going to be optimized in a way, but जो performance है उसकी वो एक point पे आके stagnant हो जाएगी even with the more amount of data coming in. I mean, unless there is a new feature that you're going to implement or going to give to your algorithm, otherwise with features in hand, the overall performance उस तरीके से improve नहीं कर रही थी. Versus in deep learning, with more features, with more data in a single feature coming in, what deep learning is trying to figure out is that it's trying to figure out the underlying connectivity between the features. So that's why with more amount of data, the performance increases in deep learning. So the analogy of deep learning is actually came from human mind. So how the human mind how the human mind thinks. So it thinks exactly, अगर आप देखें तो we have a human cell जो है इंसान के दिमाग में एक न्यूरॉन होता है. उस न्यूरॉन में बेसिकली डेंड्राइट्स होते हैं, देन उसके पास सेल की बॉडी है, देन उसके बाद एक आउटपुट है. इन द सिमिलर वेज, सो यहाँ से इंफॉर्मेशन आपके पास प्रोसेस करके आपके सेल में आ रही है, और सेल में आप यहाँ पे कोई डिसीजन मेकिंग कर रहे हो, देन अगेन आप जो है वो आउटपुट जनरेट कर रहे हो. इन सिमिलर वे व्हाट वी ट्राइंग टू अचीव इन डीप लर्निंग इज दैट हम वेरिएबल्स ले रहे होंगे, इनपुट फीचर्स है हमारे पास, जिस तरह v1 है, v2 है, कैन गो अप टू v2n, एंड देन देयर इज some mathematical equation, ठीक है, a linear equation generally represented as mx plus c, line equation जो आप लोग पढ़े होते हैं, जिसमें intercept है and आपका slope है. So that equation takes what your variables, ठीक है. So in this case आपका x है, वो आपका x1 है, x2 x3 है, and then weights हैं आपके जो कि multiply होंगे, एंड देन उसके पास प्लस आपका एक बाइस यूनिट आ रहा होगा जो कि इस न्यूरॉन के अंदर इनपुट आता है, एंड देन इसके अगेंस्ट आप एक लीनियर इक्वेशन जनरेट करोगे. सो दीज वेट्स आर अगेन कॉन्फ़िगरेबल. जब आप बैक प्रोपेगेट कर रहे होगे तो आप इन वेट्स को अपडेट करेंगे. सो दिस इनपुट इज ऑलवेज गोइंग टू बी फिक्स. ये आपकी वो इनपुट है जो आपके फीचर्स हैं जो आपने इनपुट किए, एंड देन वेट्स वो हैं जो कि कॉन्फ़िगरेबल है. सो मे बी इनिशियलाइज आप करोगे इनको 0 से भी कर सकते हो, 1 से भी कर सकते हो, रैंडमली इनिशियलाइज कर सकते हो, जिस तरह भी आपको इनिशियलाइज करने के देयर डिफरेंट टेक्निक्स देयर, बट आप कुछ सर्टेन इनिशियलाइजेशन करोगे, यहाँ पे कंप्यूटेशन होगी, एंड देन आउटपुट जनरेट होगी. जब आउटपुट जनरेट होगी तो इस आउटपुट को देखा जाएगा कि इस आउटपुट ये कितनी एक्यूरेट आउटपुट है. सो उसके लिए लॉस फंक्शन होता है. वो लॉस फंक्शन अब बहुत डिटेल में डिस्कस करते हैं, लेकिन ये लाइक लॉस फंक्शन है, वो ये देख रहा है कि जी आपकी आउटपुट कितनी एरर कितना जनरेट किया. सो लेट्स से आपके पास अगर हाउस प्राइस की मैं बात करूं, जिस तरीके से मैं पहले कह रहा था, तो आपके पास लेट्स से नंबर ऑफ डोर्स आ रहे हैं, लोकेशन आ रही है, एरिया आ रहा है, मस्जिद के करीब है, दूर है, वट एवर, देयर आर सो मेनी फीचर्स. तो वो हर फीचर को इनपुट लेकर उसके अगेंस्ट एक आउटपुट जनरेट करेगा. सो जो आउटपुट होगी विल सी कि जी आपकी जो एक्चुअल आउटपुट थी, एक्चुअल जो प्राइस थी वर्सेस जो आपने प्रोडक्शन प्राइस है, वो कितनी ऑफ है. अगर तो इफ इट इज वेरी ऑफ, देन वो जितने भी जो भी एरर होगा वो एरर बैक प्रोपेगेट होगा, एंड सी के W1 से कितना एरर आ रहा था, W2 से कितना एरर आ रहा था, इसी तरह W बाकी N से कितना एरर आ रहा था, एंड देन वो उसी एरर के साथ से आप उसको उन वेट्स को अपडेट करोगे, एंड देन दिस प्रोसेस गोज ऑन एंड ऑन एंड ऑन. सो आपकी इंफॉर्मेशन आ रही है, हर नया सैंपल जो है वो इसी तरीके से प्रोसेस होता है. द नेटवर्क सीज के जी अच्छा मैंने आउटपुट जनरेट किया है, एरर आया, उसने उसको अब सेट किया, अपडेट किया, देन नेक्स्ट सैंपल आया, आउटपुट जनरेट की, अपडेट किया, नेक्स्ट सैंपल आया, आउटपुट जनरेट किया, अपडेट किया. सो इन दिस वे जो है वो अपने आप को वो ट्रेन कर रहा होता है. सिमिलर वे एनालॉजी जो हमने बिल्ड की, हमने कहा जी कि ह्यूमन ब्रेन वर्क्स इन सिमिलर वे. सो एक बच्चा जो है वो विद एक्सपीरियंस वक्त के साथ साथ जो भी उसको एनवायरनमेंट से रिस्पॉन्सेज मिल रहे होते हैं, उन रिस्पॉन्सेज की बेसिस पे वो सीखना शुरू कर देता है. ठीक है, इसी तरीके से वी आर ट्राइंग टू बिल्ड अ मॉडल जो कि बेसिकली उसका रिस्पॉन्स यहाँ पे उसका लॉस फंक्शन है, और एक्सपीरियंस जो है वो बेसिकली उसकी इनपुट है. सो इनपुट आप पास से लेकर आ रहे हो और रिस्पॉन्स आप जनरेट कर रहे हो यूजिंग द लॉस फंक्शन. Okay, so in this way, this was a single neuron, but we cannot learn all the experience in a single neuron. So we have multiple. We can have multiple neurons. So we can have multiple input layers where all the input information is being gathered, and then we can push that information into hidden layers. जहाँ पे हमारे पास जो multiple neurons हैं जो कि आपस में information exchange कर रहे हैं. And each neuron, just you can see that the information coming from this neuron is going to this, and this, all of these neurons. So in this way, it is trying to figure out the complex patterns hidden in the data set. So let's say maybe house price prediction के केस में आपके पास जो है वो एक सर्टेन लोकेशन के साथ अगर स्कूल एग्जिस्ट करता है तो उसकी प्राइस बेटर है वर्सेस एक अदर लोकेशन के साथ अगर स्कूल एग्जिस्ट करता है तो उसकी प्राइस वर्स है. सो दैट रिलेशन इज आप उसको फीचर्स अगर मशीन लर्निंग आप कर रहे हो तो यू हैव टू प्रोवाइड अ सर्टेन फीचर फॉर दैट. ठीक है, आई मीन यू नीड टू गिव दैट इंफॉर्मेशन टू योर लर्निंग मॉडल. बट deep learning में it is going to figure out that underlying relationship between the data columns. सही है. So इस तरीके से जब information आपस में exchange हो रही होगी तो वो multiple features को combine करके एक नया feature generate करेगा. इसी तरीके से वो हर layer के अंदर with all the new layers वो hierarchy में with इसी तरीके से hidden patterns generate करता जाएगा and eventually एक output generate कर रहा होगा. So जो output होगी उस output के against आप वापस जो है वो अपने जो जितनी आउटपुट आपकी ऑफ होगी उस आउटपुट को फिर अगेन आप टेस्ट आउट करोगे कि वो इतनी ज्यादा एरर जनरेट किया. वो एरर जो है फिर आप बैक प्रोपेगेट करके सारे वेट्स को अपडेट करोगे कि जी चाहिए सर्टेन वेट से ये एरर जनरेट हुआ है तो इस वेट को अगर मैं लेट से प्लस कर दूं या माइनस कर दूं तो मुझे जो एरर है वो रिड्यूस हो जाता है. तो इस तरीके से आपका जो है वो नेटवर्क ट्रेन होता है. बाकी इसकी डिटेल्स जो है ईपॉक्स क्या होती हैं, एक्टिवेशन फंक्शंस क्या होते हैं, लर्निंग ऑप्टिमाइजर्स क्या होते हैं, लर्निंग फंक्शन क्या होता है, ग्रेडिएंट डिसेंट क्या होता है, ये सारी चीजें हम कोर्स में डिटेल में डिस्कस कर रहे होते हैं. सो मेजर रेवोल्यूशंस किस तरीके से आई. सो कंप्यूटर्स वाज देयर ऑब्वियसली. कंप्यूटर्स के बाद इंटरनेट एंड देन फिर मोबिलिटी, मोबाइल डिवाइसेस. एवरीवन इज नाउ एवरीवन हैज अ कंप्यूटर इन हिज हैंड. और उसके बाद फिर नाउ all of the data we have deep learning in place, and deep learning के थ्रू हम जो है वो consumer के experience को enhance कर रहे हैं. We are trying to enable consumers in different industries. We are trying to figure out how we can optimize their experiences. Buying experiences कैसे optimize कर सकते हैं, उनकी traveling experience कैसे optimize कर सकते हैं, उनके air travel कैसे optimize कर सकते हैं, इसी तरीके से उनकी जो food experience है वो कैसे optimize कर सकते हैं. So all of those revolutions are coming because of the fact that we are now able to capture a lot of data and process them in complex algorithms where the algorithms are helping us to figure out the underlying patterns rather than we telling the algorithms that these are the extract features that we have and you are going to figure out the non-parametric equation. But in deep learning, we are actually giving all the data, all the raw data to the models, and the models are basically telling us that this is the underlying pattern that the data is having. So in the same way, now we are able to build self-driving cars where it's basically a mixture of computer vision with deep learning. So where we are trying to actually capture frames from the real environment and then decision making जो हम कर रहे होते हैं गाड़ी की के हमें accelerate करना है, brake करना है, लेन चेंज करनी है या फिर अपने जो है वो टर्न लेना है अगर सर्टेन किसी लोकेशन पे जाना है. So all of those decision making जो process है that is being done after processing the information in by using computer vision. So computer vision we will discuss in detail how deep learning algorithms like CNN are helping us to optimize the computer vision problems and how the information is being processed in a convolution neural network. In fact इस session में भी थोड़ा सा उसका एक overview दे रहा हूँगा. So similarly, then आपके पास speech recognition का use case है where you can recognize whatever the आप speech translation कर सकते हैं, उसके बाद semantics निकाल सकते हैं, इस तरह के बहुत सारे काम कर सकते हैं. उसकी example है NLP की example है API.ai. You can go and explore it yourself. इसी तरीके से image captioning है, computer vision का case है जिसमें आप if you provide the model with the image तो वो आपको उसको कैप्शन करके देगा कि what's happening in the image. इसी तरीके से फिर आपके पास कैंसर प्रिडिक्शन का है, जो फिर इन सेलुलर लेवल आप जो है वो you're trying to figure out कि whatever the differences between multiple cell information, और वहाँ पे आप you're trying to figure out कि the person has cancer or not, or no cancer, or it is going to have cancer in future as well. इसी तरीके से सेल्फ ड्राइविंग कार्स हैं, उसमें all the information is being captured from the different I would say IoTs, and then उसको प्रोसेस करके जो है वो डिसीजन मेकिंग कर रहे हो, जो कि हमने पहले भी देखी थी। सिर्फ मशीन ट्रांसलेशन, जिस तरह मैंने बताया था कि आप जो है वो टेक्स्ट को कैप्चर करके उसको यूजिंग NLP आप ट्रांसलेट करके वापस कंज्यूमर्स को हेल्प आउट कर सकते हो। पोस्ट जनरेशन है, आप देख सकते हो कि if a person is actually standing, sitting, रनिंग, और एंड देन इसी तरीके से फिर उसकी एक्सरसाइज क्या है, कितना कैलोरीज बर्न की है, और कनेक्टेड बहुत सारी चीजें होती है, कौन सी टीम कैसे परफॉर्म कर रही है, इसको स्कोर किसका बेहतर है, एंड ऑल। लेटेस्ट स्टेजेस पे आप आगे प्रिडिक्ट भी कर सकते हो कि इट इज व्हिच टीम इज गोइंग टू हैव अ बेटर गेम प्ले कंपेयर्ड टू अदर। And then neural style transfer, where you can combine multiple, you can apply a filter on a certain image and create new images. इसी तरह फिर डीप ड्रीम्स का भी आगे मैं दिखा देता हूँ। म्यूजिक जनरेशन, आप न्यू म्यूजिक जनरेट कर सकते हो यूजिंग डीप लर्निंग। फेस जनरेशन का है जनरेटर, GANs हम पढ़ रहे होंगे इसी कोर्स के अंदर, जहाँ पे विल सी कि हाउ जनरेटिव एडवर्शियल नेटवर्क से होते हैं वो किस तरीके से फेस जनरेशन करते हैं। दिस फेस जो मैं आपके सामने दिखा रहा हूँ, these people actually does not exist. These are generated faces by a algorithm called GAN, और इसका ऑब्जेक्टिव यही होता है कि it learns from past, from noise of data, and then basically adjust its weights in a way that whenever some new noise is given to the algorithm, it generates whatever आप जिस पे learn किया। So if it has learned on generating faces, तो ये faces generate करेगा। If it has learned to generate other things like maybe कोई rental generate कर सकता है, like कोई room की setting generate कर सकता है, कोई animal का face generate कर सकता है। इसी तरीके से वो कोई सर्टन आपने गेम प्ले अगर बनाया हुआ है, कोई गेम का मैप है, कोई लेवल आपने बनाया तो वो जनरेट कर सकता है। सो इस तरह के बहुत सारे, वो अगर आपने कोई पजल जनरेट करना है तो पजल जनरेट कर सकते हैं। नाउ दिस GAN नेटवर्क्स हैज बीन इंट्रोड्यूस्ड रिसेंटली 2014 में जो है वो फर्स्ट पेपर इसका इंट्रोड्यूस हुआ था, और उसके बाद फिर 2015 के बाद जो है वो DC GAN के बाद काफ़ी सारे इसके यूज केसेस जो है वो इम्प्लीमेंट किए जा सकते हैं, और काफ़ी इंडस्ट्रीज में इम्प्लीमेंट किए जा रहे हैं। डीप ड्रीम्स, प्रिसिजन मेडिसिन आपने देखनी है, साउंड अगर स्टोर करना है आपने वीडियो के अंदर, इसी तरीके से आपने जो है वो टेक्स्ट ट्रांसक्रिप्शन करनी है लिप मूवमेंट से, इमेज एनहांसमेंट करनी है, पिक्सल रिस्टोर करने हैं, OCRs करने हैं। ऑल ऑफ दीज यूज केसेस कैन बी डन यूजिंग डीप लर्निंग। इसी तरीके से so what we are trying to achieve is we are going beyond the human level performance. So deep learning industry leaders, if you talk about that, so Facebook, Microsoft, Google, all of these industries are basically pioneers in many different algorithms. I mean, the person who has presented GAN is currently leading Google Brain, and इस तरीके से Facebook ने जो है वो PyTorch का framework शेयर किया, Google ने TensorFlow framework शेयर किया. So and then there's so many different frameworks in which you can perform deep learning. So Caffe है, TensorFlow है, MaxNet है, Microsoft का CNTK है, PyTorch है, Theano है, Keras है. So in our course we'll be only discussing TensorFlow and Keras, but PyTorch is there. Generally PyTorch पे भी थोड़ा सा लोगों का focus आजकल ज़्यादा है, लेकिन ये कि we can at least cover the basic understanding of how the deep learning algorithms are working, how they can be implemented on different use cases. So वो हम TensorFlow और Keras में कर सकते हैं. So we'll be exploring TensorFlow and Keras. Tools में आ जाते हैं. So we'll be discussing, we'll be implementing all of the things in Python, and we'll be using Anaconda to basically manage all the packages that we are using in Python, and Jupyter Notebook will be served as an IDE, जो कि आप कोर्स में कर रहे होगे. But recently, because of the fact that जो deep learning के algorithm के जो implementations होती हैं उसमें data sets के size काफी बड़े होते हैं, तो I do prefer using Google Colab rather than using coding on your own local machine. So Colab पे generally मैं ज़्यादातर equation करवा रहा होता हूँ end-to-end notebooks. और Conda पे we are able to generate virtual environments, and उसके लिए आपके पास let's say आपने कोई नई environment create करी. So what is the objective advantage of creating environments is, let's say multiple people are working in a certain team, and एक बंदा जो है केरास के certain version पे काम कर रहा है, एक बंदा जो है वो scikit-learn के किसी version पे काम कर रहा है. तो we can have multiple environments for each of them, ठीक है, we can have a single environment for each of them, और उस तरीके से हम जो है वो, and इस तरीके से conda create है dash name करके आप उसको environment का नाम देते हो py3, and then आपने python का variant उसको बता दें कि 3.7.2 करना है. So अगर आपने एक्टिवेट करनी है environment, तो py3 आप एक्टिवेट कर सकते हो, डीएक्टिवेट कर सकते हो, रिमूव कर सकते हो, क्रिएट कर सकते हो, आप सारी environments लिस्ट कर सकते हो. जैसे दो मैंने अब बेसिक कमांड्स है, कोंडा चीट शीट है, आप जाके गूगल पे सर्च कर सकते हो, आपको सारी की सारी मिल जाएंगे. आप किसी इन्वायरमेंट को एक्सपोर्ट भी कर सकते हो. अगर आपने लेट्स से अगर एक सर्टेन इन्वायरमेंट है, आपको वो इन्वायरमेंट किसी और लोकेशन पे जाके रेप्लिकेट करनी है, तो आप सिंपली एक्सपोर्ट करके वहां जाके एक न्यू इन्वायरमेंट क्रिएट कर दो यूजिंग द फाइल नेम requirements.yml करके. So basically इसकी चीट शीट अवेलेबल है. It's not something very necessary for you to learn, but it's just for exposure के using Conda आप multiple environments आप create करके उनको manage कर सकते हो easily. Environments create करने का जैसा मैंने advantage बताया था कि सिर्फ ये advantage है कि if you're working on multiple projects, maybe a project is running on Python 2.7, the other project is running on Python 3.7, तो you can मतलब create multiple environments और उसमें आप environment switch करके अपने project को run कर सकते हो, develop कर सकते हो. इस तरीके से आपने अगर कोई सर्टेन पैकेज इंस्टॉल करना है, तो आप इंस्टॉलेशन का कमांड है, इंस्टॉल कर सकते हो, numpy इंस्टॉल कर सकते हो जिसका फॉर एग्जांपल. इसी तरीके से आपने मल्टीपल पैकेज इंस्टॉल करे, तो मल्टीपल पैकेजेस के नेम इंस्टॉल कर दे के इंस्टॉल कर सकते हो. तो आपने अगर कोई सर्टेन चैनल से पैकेज इंस्टॉल करना है, तो आप वहां से उसका पैकेज नेम प्लस वर्जन, उसकी बिल्ड स्ट्रिंग्स व्हाटएवर जो भी आपको अवेलेबल है वो सारा का सारा इंस्टॉल कर सकते हो. जैसे आप कोई पैकेज अगर आप रिमूव करना है, आप रिमूव भी कर सकते हो, अपडेट करना है तो अपडेट भी कर सकते हो. इस तरीके से आपने अगर लेट्स से आपने ब्यूटीफुल सोप एक पैकेज है फॉर वेब स्क्रैपिंग, अगर आपने वो यूज करना है तो आप सर्च करके इंस्टॉल कर सकते हो. इसकी भी अगेन चीट शीट अवेलेबल है. और देन जुपिटर नोटबुक है. जुपिटर नोटबुक का बेसिकली एग्जैक्टली आर्किटेक्चर ऐसे है कि आप अपने पास जो है वो एक वंस यू हैव कोंडा इंस्टॉल्ड इन योर मशीन्स, तो आप उसके बाद जो है वो कोंडा के थ्रू एनाकोंडा के थ्रू जुपिटर नोटबुक लॉन्च कर सकते हो. पहले आपको जुपिटर प्रॉब्लम इंस्टॉल करनी पड़ेगी. उसके बाद अगर आप जुपिटर लॉन्च करते हो, तो इट इज एक्चुअली अ notebook server running on your machine, ठीक है, which is trying to get information from a kernel. So इस केस में हमारे पास जो है वो Python kernel हम यूज कर रहे होते हैं. कोंडा के थ्रू आप इस तरह इंस्टॉल करोगे जुपिटर, और अगर आपको NB कोंडा के थ्रू भी आप कर सकते हो अगर आप करना चाहो तो. कर्नल जो है वो पाइथन के अलावा बाकी कर्नल्स भी सपोर्ट कर रहा होता है, लेकिन जनरली आप जो है वो पाइथन कर्नल ही यूज कर रहे होते हो. और इसका एडवांटेज सबसे बड़ा ये है कि नोटबुक्स, क्योंकि एज द नेम सेज आप इसके अंदर जो है वो सेल ब्लॉक्स हैं. सेल ब्लॉक्स के अंदर आप या तो अपना HTTP कंटेंट लिख सकते हो, या फिर आप जो है वो कोड लिख सकते हो. सही है. सो यू कैन प्रेजेंट योर डेटा इन अ वेरी क्लीन फॉर्मेट, एंड as the cells are there, so क्योंकि Python कोड कंपाइल नहीं कर रहा होता, रन टाइम पे रन कर रहा होता, there is no compiler in Python. So इसलिए जो है अगर आप कोड्स में रन कर रहे हो, तो it's easy for a person to handle the information in multiple variables आपके पास अवेलेबल है. आप एक वेरिएबल को दूसरे वेरिएबल के साथ अगर आपने कोई प्रोसेसिंग करनी है, उसकी कोई ट्रांसफॉर्मेशन करनी है, कोई फिल्ट्रेशन करनी है, आपने जॉइन शॉइंस लगाने हैं, इस तरह की जो भी एक्टिविटी आपने करनी है, तो सारे प्रोसेसिंग कर सकते. इस तरीके से अगर हमने लेट्स से प्री प्रोसेसिंग के लिए कोई एल्गोरिथम अप्लाई करने हैं उस पर, और उसके बाद फिर उसको आफ्टर अप्लाइंग प्री प्रोसेसिंग आपने उसके ऊपर कोई डेटा साइंस का मॉडल अप्लाई करना है, तो ऑल दोज प्रोसेसेस कैन बी रन इन अ जुपिटर नोटबुक इन ईच सिंगल सेल. So we'll explore that in detail. Jupyter Notebook किस तरीके से चल रहा होता है. It's basically, initially it was for Julia, Python and R, but right now it supports more than 10 different kernels, I think. काफी सारे different support इसके भी exist करते हैं. इस तरीके से जो packages हम लोग use कर रहे होंगे, we'll be using NumPy, we'll be using Pandas, Matplotlib and SciPy. SciPy से ज़्यादा we're going to use Seaborn for data visualization, and then later on we're going to use the deep learning frameworks like Keras and TensorFlow. The book that we recommend for you to read before or even during the course is Ian Goodfellow की deep learning की book है. ये you should know. So अभी तक किसी का कोई सवाल हो, please go ahead before we jump into convolution neural networks. Is AI connected to Metaverse or Web 3.0 also? Yes, AI is a tool to enable basically. So in Metaverse, let's say you have a certain game that you're trying to play. Maybe you're trying to buy a property or whatever. So your experience is going to be enhanced using AI. I mean, अगर आपका game play है, you have an opponent and you're playing against a computer, so it can be intelligent enough to beat you in your gameplay. So AI as a use case can be, I mean, applied to any other platform. It's not मतलब, I mean, आप इसका connectivity कहीं से kill नहीं कर सकते. There are all the platforms that are available to you that has connection to data are going to use AI. So which approach should we use, deep learning or machine learning? Ata, basically you need to understand the core the difference between both. Machine learning, as I said earlier, is dependent a lot on your features. I mean, if your features are incorrect, if your features are not explained enough to address the problem that in hand, मतलब जो भी आपका target variable है, अगर उससे उनकी correlation बहुत off है और उसके बाद वो उस problem को सही तरीके से address नहीं करे, so your machine learning is not going to reflect you any answers. I mean, आपकी जो evaluation metrics हैं in regression or even in classification, आपके जो भी आप metric आप basically validate कर रहे हो, I mean, आप precision देख रहे हो, recall देख रहे हो, या आप F1 score देख रहे हो, या आप R2 देख रहे हो, या MSE देख रहे हो, whatever metric जो भी आप देख रहे हो, metric आपका जो है ना वो इतना close enough नहीं होगा, ठीक है? It is not going to be satisfied. आपका satisfaction level achieve नहीं हो सकता वहाँ से. But जब deep learning आप apply करते हो, so in that case आपको ना, so you have this confidence के if certain problem का जो connectivity है between the features and how the features can be utilized to solve that problem, if there is no certain connectivity, so what you can do is कि आप जो है ना वो बहुत सारी raw information जो है वो deep learning से process करवाओ, ठीक है? If you have a lot of different angles to look at the data, if you have a lot of different dimensions to look into the data, तो उस case में फिर you get I mean, advantage of deep learning is there. Is for that certain reason आपके पास जो है वो, जैसे for example pictures have a lot of data inside them, right? So अगर आपने pictures segmentation करनी है, ठीक है, image segmentation करनी है, so you need to segment images, let's say between cat and dog. So there's a lot of different information coming in. So deep learning are better approaches to solve this kind of problem rather than machine learning. I'm studying the metaverse, so how can deep learning will enhance me if you can guide? Obviously, it is going to be dependent on the use cases that you're studying in metaverse, but I cannot exactly answer this question. I mean, I can teach you deep learning in detail. How it's connected to metaverse, I need to see exactly कि वो कितना कौन से use cases हैं जो metaverse में use हो रहे हैं. I'm not really sure metaverse में कौन से use cases use होते हैं deep learning इस moment पे. लेकिन but again, as I earlier said, then कि जो आपका platform है वो, if there is some intelligence involved, that can be that is required, तो वो is going, then definitely deep learning is the process जिस तरीके से आप उसको achieve कर सकते हो. Are we going to discuss the AI career prospects in Pakistan or globally? So deep learning career in terms of that, if you're asking me job opportunities, yes. देखो, job opportunities Pakistan के अंदर, we have a lot of different cost centers available in Pakistan. So I mean, बहुत सारी research, बहुत सारा जो है वो implementation जो है ना वो पाकिस्तान में different startups कर रहे हैं, ठीक है. अगर आप telecom sector या कॉर्पोरेट सेक्टर्स जो आपके हैं, FMCGs हैं, वहाँ पे डीप लर्निंग की बहुत ज़्यादा यूटिलिटी नहीं है इस टाइम पे. आई मीन मशीन लर्निंग की यूटिलिटी रिलेटिवली बहुत हाई है, लेकिन डीप लर्निंग की यूटिलिटी बहुत ज़्यादा नहीं है. बट अगर आपने जिस तरह कंप्यूटर विजन है या NLP है, यहाँ पे अगर प्रोग्रेस करना है, then there are a lot of different startups out there जहाँ पे आप after doing the course you are capable enough to compete for the positions. So but keep in mind but that के जो आपके corporates, especially FMCGs, banking sector, telecom sector, retail sector, they do not have that kind of deep learning use case. At least अभी तक मैंने नहीं देखा, ठीक है. So आपका जो है ना वो job market जो है is going to be around pivoting around the lean startups where they're implementing new ways of creating business. So वहाँ पे आप बेहतर होगा. How much? Okay, so it's there are a lot of questions coming in. How much math do you need to learn for AI, and what level of mathematics is required? I mean, it's all about mathematics, Hassan. It starts from a simple parametric equation, but linear algebra is really important. And this is तरीके से फिर आपके पास जो है वो differential equations is important, and then multivariable calculus also important. So to understand the underlying capability of the algorithm and how it works, all of these concepts need to be learned. At least base level concepts clear होने चाहिए. बाकी ये कि if you want to go into research, then your math skills should be very high, very good. But if you're working in the industry, so it's more about application. So application के case में, it's not necessarily important for you to have a very expert level mathematical skills, but yes, some mathematical skills are required to understand at least what's happening inside the algorithm and how it is being so that you can actually evaluate your approach. I mean, if you're not able to evaluate your approach, you don't know exactly what you're implementing. So that's why you need at least basic knowledge of linear algebra, differential equations, multivariable calculus at least. As how much computational power is required to apply deep learning models? It is again subjective, Jawad, because computational power is again subjective to the amount of data that you have. I mean, you can create a deep learning model on your Core i7 laptop of maybe your 5th generation laptop, but that's again subjective because the amount of data that you're processing, maybe some 1,000 images, you're good to go. But if you have millions of images, then definitely you need a lot of computational power. I'm working on medical disease analysis, and deep learning is being widely used. True, I'm studying augmented reality, which I think it requires different task. Okay. Can you repeat the difference between ML and DL? Which approach is better? Okay. Computer vision engineer in which industry can apply? Electric engineer having experience of AI. Okay, so आप लोगों के ना बहुत सारे क्वेश्चंस हैं और वो सारे के सारे जो है ना वो आपस में लिंक भी नहीं कर रहे. So I'll talk about 3 things at least जो मुझे लग रही है important है, and then we'll see if I have time to reflect on other questions as well. So first thing first, a person said that which approach is better? Again, as I said earlier, it is for the amount of data that you're trying to process and amount of features that you're trying to process. If you have a lot of features and a lot of data, then deep learning is the right way of implementation. But let's say with a limited amount of features, you can achieve your results by using machine learning as well. So by limited amount of features, I mean maybe you have 20, 30 features, or maybe 100 features with the sample size of maybe 1 million or 2 million. So it is, you can process the data in machine learning. But for deep learning, so again, the numbers that I'm quoting are again subjective. It's not like there's a mathematical formula out there to differentiate between approach of ML and DL. So it is again subjective on the domain, on the on the problem set that you're having. So for images, for image processing, deep learning is better. For speech recognition, for text semantics, deep learning is better. But for data sets of for structural data set, like maybe a data set of retail industry, or a data set of high ride hailing industry, or maybe a data set generating from telecom industry, we do apply machine learning algorithms, and we get good results. In terms of industry, if someone asks that if they have experience of AI, which industries are there for this, initially I've discussed this in the first slide. Okay, all of the industries are utilizing AI as the way to optimize their business. But in Pakistan, I've specifically saying about Pakistan, that in Pakistan, the big corporates like telecom, banking, retail, FMCGs, they're not very much into deep learning at the moment. I mean, there are people who do know stuff, who do know exactly how deep learning works, but the products that we have in telecom or banking or FMCGs or in retail or ride-hailing industry or e-commerce, like Daraz and OLX, we do not see such implementation of deep learning. At least I'm not aware of. But then again, there are so many startups out there who are trying to build applications for the international industry, for the same sectors. I mean, for the for the medical industry, for education industry, for ride-hailing industry. They're building solutions for them to basically to figure out how they can create business from them, how they can optimize this business from them. But the businesses that are running inside the Pakistan, they are not spending a lot on this on the deep learning part. But yes, we have dedicated resources for data science, and we have dedicated resources for descriptive and predictive analytics, where we are trying to figure out how we can leverage this whole knowledge to basically have a better way of doing business. So okay, so how much data preparation, how much learned data preparation do you need AI learn? Also, what level statistics analyst will be insightful? I don't know exactly what you're trying to ask. So I think the question was about to implement AI, how much data preparation we need to learn, and how much statistical analysis that we need to be equipped of, so that we can have a better insights inside the data. I think this is again a question that cannot be measured. I mean, these things are not we don't have a certain metric for this. I mean, you cannot say that I am going to be ranked as 8 out of 10 or 10 out of 10 as a statistical analyst. I mean, there are so many different techniques out there, and there's so many different ways to solve the problem. So what my suggestion would be that you start from small, and then you start building up the whole suit. So if you're doing data preparation, you need to understand how to acquire data, how to process data, how to build pipeline if you're doing it for a certain business, and then maybe try to figure out how we can apply scientific methods to process the data. I mean, if there are any certain missing values, so maybe you can simply impute them by taking means, or maybe have a certain business formula for the imputation, or maybe you can have use scientific method of like maybe you can use nearest neighbor to impute your missing values. But again, this is iterative process, and it's not like you need certain amount of knowledge to start working. You can start working with very basic knowledge, and with experience you uh, basically explore the problem. So a problems I was solving 3 years back, I had a different view about it, but right now I have a different views about it. Same problem, I have different views about it. So the reason behind is that now I'm able to see the data set in different way. Comparatively, I was seeing it in 3 years back. So that would be enough. Okay. So which course I'm talking about? I'm talking about both courses, DSL/ML. If someone wants to work in data science or AI field, and then the course we're offering is a data science and machine learning course, where we actually teach from scratch. So we try to enable you on Python first, and then we try to give you an intuition of a regression, how the regression problems are solved, and then we try to give you knowledge about the probability, and there's different um, uh, the different theories available to you, but what we're trying to do is that we're trying to give you practical implementation of different data sets, and whatever algorithms that you're learning in your course, we are trying to give you an exposure of those the output of those algorithms. And then from regression we jump to classification, discuss few algorithms, the inside working of those algorithms, and then we discuss the clustering part, where unsupervised learning, k-means clustering, how it works, dbScan, how it works, hierarchical clustering, how it works, what are the differences between all of these different techniques, how we are going to evaluate which is the better technique to solve a certain problem. So there are certain indices like Silhouette index, there's adjusted rand index. There are different indices that we're trying to measure and then see if the clustering that you've done has a certain impact or not. And then we explain how other algorithms like rule, if you're trying to figure out certain rules, if you're doing rule mining, so how a priori algorithm works. And then we have projects for each of these techniques. So we give you projects for yourself to solve, and we evaluate you on those projects. And then the next part is if you're done with the DSML part, then we offer deep learning, where initially you are exposed with Python data structures, Python language, control flows, how we can write functions, how we can write programs in Python. And then again, we jump to so if we jump to deep learning part, where we're trying to explain what is exactly artificial neural network, what is the mathematics behind the artificial neural network, how the backpropagation works, what is the chain rule, how the loss function is optimized, what exactly you mean by gradient descent, and then what exactly you mean by loss function, how you're going to optimize for loss function, what is global minima, local minima, how optimizers works, how activation functions works. All of that knowledge is being shared in deep learning course. And then we jump, after we're done with the multi-layer perceptron part, then we jump to convolution neural networks, where we discuss how convolutions works. And then once we're done with that, we do two different projects, and then we jump to long short-term memory networks, where we're trying to figure out, initially we explore recurrent neural networks, where we're trying to figure out how time series problems can be solved using deep learning. And then we do explore the challenges being faced in RNNs. And then we explore LSTM, long short-term memory networks, where we have multiple cells, and we see how the cells are being basically evaluating the information, learning from the information, what exactly we mean by long-term memory and short-term memory, how the memory is being updated. And then once we're done with LSTM, then we explore GAN network, how generative adversarial networks works, how generative network is working, what is the working of discriminative network, and then we do implement a project in the same. Then in the last part, we explore transfer learning, where we can basically utilize some old already computed algorithm architecture to be implemented in a new in your own data set. So, and then we have again a project in the end where you are being marked on your learnings. It's mostly about transfer learning. So that's what we are trying to teach in our course. Do we need Python beginner skills to start this course? Someone who's familiar with the programming can take up. You don't need exactly Python beginner skills. I mean, if someone is has a small familiarity with the Python in any programming language, the person is able to adopt, because all of these courses, DSML and deep learning, we do teach Python in detail in a first week session. In a first week session, we do teach Python in detail. So what are the data structures? Again, I mean, I've explained that in detail. So we do teach Python, so you don't need have to have a beginner skills. It's totally fine if you don't know Python. We do teach you that. Okay, I think let's jump back to convolution neural network. So I think it's a bit hard for a person to understand exactly what convolution neural networks does, but because if a person do understand how multi-layer perceptron works, then it is relatively easier for a person to understand how convolution neural networks work. But still, let's have just a glimpse of how these networks work. So what convolution is about, it's about creating a building blocks of convolutions to merge two different sets of information and to produce a feature map. Basically, what exactly this means is that when you're basically extracting some information from an image, we can. So let's say if I want to segment image into cat or dog, these are two different categories. I have images of, let's say, 1,000. I have a certain 1,000 samples, and few of them, maybe 20% of them, are images of cats, and 80% of them is images of dogs. So how we can solve it in using a machine learning approach? We can solve it by extracting features from the image. So maybe we try to have features. What kind of features that we can have? Maybe we can have a feature like what is the size of the image, what is the width of the image, what are the objects in the image. But we need certain algorithm to extract those objects from the image. I mean, there is no other way. Image is just pixels of information. It's a 3D array with 3 different channels, red, green, and blue, and it has just numeric values in there. So so you need another set of algorithm to extract this information, the exact feature which you can use to to predict the information inside in the image. So for that reason, we have this process called convolution. So convolution, what convolution exactly does is that it creates a feature map. The feature map basically reflects the information being stored in an image. So how the convolution works exactly? So let's say this is an input image that you're having. Let's just assume this is an input image. You don't actually get 1 and 0s in your image, but let's assume that we are getting 1 and 0s. Generally, that what you get is that you do get numeric values like pixel value between 0 to 255. So let's say if you have a grayscale image, you might be getting a value here 157, 180, 190, 0, and then maybe 200. So 0 to 255 is the pixel value. and input is basically an image is a reflection of those pixel values. So you can have, so whatever this is the size of the image represents the width and height of the pixels, density of pixels in width and height. So let's say you have an image, and then what convolution is all about is applying a filter, a kernel on this image. So what kernel is that it has certain values here. So these values are actually weights that convolution network is trying to optimize to extract the right feature map. So how feature map is being developed is developed by applying the kernel on the input. So it is relatively very small and very easy step. What we're trying to achieve here is that what we're going to do is that we're going to multiply all of these values on this input. So let's say we multiplied that certain value, that filter on this, we applied that filter on this input, and all of those values are being multiplied. So we get 1 to 1, 1, 0, 1, 0, 1, 0, 0, 0, and then 1. So then we're going to add up all these values, and we're going to say that this input has a value of 4 that we're getting when applying this filter on this image. So we get a pixel value of 4. And then similarly, this convolution filter is going to be moved all along from all of the pixels. So it is, if you have a stride of 1, so it is going to move from this part, the next part, and then the next part. So it has a 3 by 3 pixel filter. So first we are going to apply it here, then we're going to apply it here, then we're going to apply it here. So in this way, we're going to get a feature map of, let's say, 4 of, and then 3. The green area, this is called receptive field, and element wise multiplication, I've already explained that to you. So after sliding once, we get a value of 4, and then we get a value of 3. This process is repeated all along for all the picture. And in this way, let's say we have a picture of 32 by 2 and then 3 pixels. So we are applying the filter on all of the pixels, and we create a single feature map. And by applying multiple features, like by applying multiple filters, like let's say we have 10 different filters. So we are going to get 10 different feature maps by this process. I'm going to explain it to you in a visual demonstration after this explanation. So just stay with me. So once we are done with the, applying this filter, we are basically getting a different feature maps. So the next process is going to be getting so let's explain what padding is all about. So padding is basically if we are going to apply, so in this case, let's see, in this case, if you're going to apply a 3 by 3 filter on this input image, you're going to get an output of 3 by 3, which is a relatively smaller output from the size of this input. So this input was of 5 by 5, but the feature map that you're getting is of 3 by 3. To reduce that, or you don't want to have, if you don't want this to happen, then you can apply a 0 padding on all of the sides of the input. So that's what we're doing here. So by applying 0 padding, we are going to get the same size image. And then strides tells us that how much we are going to move with our filter on the image. And then pooling is basically a process where we are trying to reduce the dimensionality. So as I said earlier, that we're trying to figure out what features are there in the picture. So let's say after applying the convolution, we get this feature map. And now we are trying to reduce this feature map so that we can have a lower dimension representation of this feature map. So we're going to apply max pool of 2 by 2 with if we are applying for a stride of 2, then it is going to be like this max pool is going to see that whichever the value is higher in this pool, that is going to be the next representation. So this has a 6 value, this has 8th value, this has 3 value, this has 4th value. So in this way, after applying max pooling, we get this answer. So this way, what's happened is that what happened is that we get initially we got 10 filters on 32 by 32 image, and then after applying pooling, we get half of the image. So we have reduced the dimensions to half. So after applying pooling, we get to 16 by 16, and the 10 is the amount of filters that we're having initially. So in this way, in a complete fully connected layers network, we have, let's say this is your input image. You're applying filters on these images and creating convolution layers, multiple convolution layers, which are actually a result of your filters that you have applied. And then the pooling is basically reducing the size of your convolution filter, and then basically reducing the dimensions. And then convolution is basically trying to figure out more low-level features in the image, and then again pooling is reducing the dimension. Then all of this information is being basically passed to fully connected layer, which is a deep learning network with just like a multi-layer perceptron. And then again softmax is there to basically predict multiple classifications. So if you have, let's say, 10 different classes, 10 different targets, so softmax is the activation function for to produce that kind of answers for you. So I do understand this is a little bit overwhelming for the people who are really new to this whole setup. So I have another demonstration, which I'll give it to you just right now. Give me a second to figure out the link. Just give me, and you can write your, your queries in the chat box. I'll get back to that as well. Is my screen still shared?
Right. Not visible.
Sorry?
My screen share नहीं हुई अभी.
No, okay. So this is a visual demonstration of the same process that I explained. Just let it open. So let's say this is for you to understand how convolution neural network works. So as I said earlier, that we have an image. Let's say this is an image of a koala, or this is an image of a bus. You guys are able to see my screen, right?
Yes.
So you can see that we have a different. So this image is actually is represented in pixels. So we have red channel, green channel, and blue channel. Red channel means the value of pixels in a red color. Whatever the amount, whatever the value is between 0 to 55 is representing the red color, and this is representing the green color, this is representing the blue color. So all of this information is being passed to your convolution layer, and then this kernel is applied. So I mean, this is the size of the kernel is 3 by 3, and the input image is of 64 by 64, and output is of 62 by 62. So as you can see, this weights are there. So these weights are fixed, and these weights are basically being calculated by the forward and backward propagation process. So these are the weights: 0.3, 0.21, 0.07, and this is the input image. The input image is already normalized in between 0 to 1, so that's why you're not exactly able to see the value between 0 to 255, but these are the actual values, 0 to 255 values, which are being normalized in this way between 0 to 1. And after applying the filter, as you can see, there is this dot, which is another pixel that is an output of a convolution. So this is a convolution that is being applied on this, and what we're trying to figure out is that we're actually creating a high level features from this image. And the objective of the convolution is to get first feature map, which is this one. It has 10 different filters. So these are the 10 filters. You can see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all of these images are being passed to these filters, and this information has been um, this data is being propagating forward and backward to get these weights, exactly the weights that I was showing you earlier. So ReLU is another activation function which has an objective to see which is the maximum value between 0 to 1, 0 to greater than 1 maybe. So all of the negative values, any negative pixel values are being reduced to 0, and otherwise other values are being reflected as is. So in this way, all of the negative features or negative pixel values are being kind of discarded in this case. So then again we have applied another convolution and then another ReLU function and then max pooling. So as I said earlier, so max pooling objective is to get the maximum value out of it. So as you can see that this if a max pooling filter is applied here, you can see there's the value of 0.73 is the maximum value that we are getting out of this. And this max pooling is then again applied to convolution, ReLU function, convolution, ReLU function, then finally max pooling. And after this max pooling, this is passed to a fully connected layer where the information is first flattened. Flattening means the information is being transformed into a single 1D array. So this is a 3D array having a size of 13 by 13 by 10. It is then flattened into a 1D array and then passed to another function where a complete fully connected layer has been deployed. And then a softmax is a function where is an activation function to get a probability between all of these different categories. So we have 10 different categories here, and we get a probability of 0.99 in this case. So how we are calculating it, you can go and check for the formula. So exponent of whatever the value for this and versus exponent of all other values. So this is a visual demonstration. I'll share you the link in the chat, and you can go and explore it by yourself. I mean, you can add your own images in this demonstration by clicking this, and let's see. Okay, for some reason this add button is okay. So now you can simply add your own image. And let's say if I upload and add an image of so this is a car image which I'm going to upload here, and see how this network works. So this network is again trying to convolve, put a ReLU function, and then do all the convolution, ReLU, and max pooling. And then finally it says that this is a sports car, which was the only category related to the car. So that's why it has certain probability of saying it is a sports car, and then it has a certain probability of saying it's a life boat. But as the images that you've seen, the sports car images are basically in this frontal view. So if I am going to change the view of this Miran image, then it is not going to be able to get the right answer for me. So this whole convolution explanation is down here. You can actually look in the convolutions, and then how the different parameters, hyperparameters that we have, input size, patterning, kernel size, strides, all of the information is there. Again, then activation function, ReLU explanation, and how this works. So this is just a one exploration of how we explore the CNN network. I mean, we spend more than 10 hours to understand how convolution neural network works, but in last 30 minutes I've tried to explain it to you in a very I would say fast forward format. But I mean, this is how we're going to explore in the course as well. So that's all from my side. I mean, if you guys have any other questions, you can go ahead and ask me any questions that you have. You can unmute yourself. I mean, let's try if it works now. You can write it in the chat box, or maybe unmute yourself and ask me any question regarding the deep learning, the career progression, if you're interested in that, or any other question that you have in your mind. Okay, Awais, I think that's pretty much from my side. If there's something more that we want to discuss, then let's have it. Otherwise, let's conclude the session. Okay, just asked earlier about career as a computer vision engineer. So as I earlier said that there are certain job roles which requires expertise in computer vision. Products are mostly related to different domains, like retail industry is interested for computer vision engineers. Similarly, or medical industry is also interested in computer vision engineers. I'm not really sure what you're confused about the career. I mean, can you explain me more? I mean, what you're trying to ask about your career in as a computer vision engineer? If you do understand what computer vision engineer is working on, so it won't be that much difficult for you to understand the career as well. With respect to job market of what? I mean, international market or local market? So local market, Jawad, as I said earlier, there are so many software houses, small startups that are working on different projects related to computer vision, and they're paying a good amount of money as well. I mean, people are building business. They're basically building products. They're basically trying to solve problems of businesses, but not for local market, but for international market. So they're actually building up cost centers in Pakistan. I mean, people are working from Pakistan to solve business problems outside the country. I mean, all local industry like FMCGs, retail, telecom, banking, they don't have certain use cases in computer vision. They're still evolving on the data science part. I mean, they're trying to figure out how they can leverage data science and build products around that, and then get better product, optimize their products using data science. But computer vision is the next step for them. So right now, computer vision persons are not very much penetrated in this market, but in the local markets, there are so many startups where people are working for international market. That's how I see it. Yes, Hassan. So Hassan said that to summarize CNN, the model takes images and apply some type of filter to extract particular feature, which is used by model to do certain calculation that will find the pattern as to categorize the image. Yes, that's pretty much, it explains the whole process. Any other question that we have? Wes, we can then conclude the session. I mean, if
All right. All right, so that's all about the webinar. Thank you so much, Mr. Hassan. We had a great time on this session with you. You guys can email us You guys can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. Thank you so much. Allah Hafiz.